Good morning again. Let me take up one more chapter known as linear partial differential equations with constant coefficients. Unlike linear differential equation with constant coefficients in your first semester, that was an ordinary linear differential equation with constant coefficients. This is a partial linear differential equation with constant coefficients, written as an minus 1 del nz del x n minus 1 del y so on a0 bn del n minus 1 z del n minus 1 z del z by del x del z by del y plus kz equals some function of x and y. These are the terms containing partial differential coefficient of order n. These are the terms containing partial differential equations of order n minus 1, then of order 2, then of order 1, and single, no order, and this is function of x and y. Just like linear differential equation with ordinary linear differential equation with constant coefficient, say dny dxn dn minus 1 y dxn minus 1 plus, say this is an minus 1, this is a2, this is a1 dy by dx, then a0 y equal function of x. This we have seen in our first semester. This we have done. How to solve this, you know. This is a linear differential equation, ordinary linear differential equation with constant coefficients. These are all constants. Okay, this could be a linear differential equation with variable coefficients if these an minus 1, a2, a0 are variables. Okay, now this is like this only. These are the terms of order n, of order n minus 1, of order 2, of order 1, of no order, and this is function of xy. Here it was function of x. So this is known as linear partial differential equation with constant coefficients. Okay. Now this is known as linear partial differential equation, homogeneous linear partial differential equation of order n if we have only this thing. All the terms containing in the equation are of same order. All the differential coefficients in it are of order n. This is a linear homogeneous linear partial differential equation with constant coefficients. An, another derivative, an minus 1, another derivative, x and y, and so on. And another derivative with respect to y, and function of x, y, both x, y, because that is function of x and y. Now, how to solve this equation? This is symbolically written as an, nth derivative. This is partial derivative with respect to x. Remember it once for all. We write d here, it is del by del x, and d dash is del by del y. So this is an d raised power n, this is an minus 1, this is d raised power n minus 1, x raised power n minus 1, and this is only one d dash. Then plus so on, a0, this is d dash raised power n, operating on z equal function of xy, or symbolically we denote it as f d dash operating on z equal function of xy. This is a homogeneous partial differential equation with constant coefficients, right? Homogeneous partial differential equation with constant coefficients. just like unlike linear differential equation with constant coefficients, what was that? F of d operating on y equals some function of x. Instead of x, we have y as well here, and x and y are functions of z. That is why d and d dash are operating on z, giving us some function of x and y. Here fd was operating on y as giving us a function of x. Now you know how to solve this equation. You are finding the complementary function and particular integral. Here only we do have to do same thing. We have to find the complementary function and the particular integral. Now let me tell you what is the working rule for finding solution of this equation. Solution is same. You have to find complementary function and particular integral. Now how to solve that, how to arrive at that, let me tell you. Let me give you the working rule. See, working rule for solving 1. Say this is 1, this is 1, and this is also 1. Same. All are 1. This is the symbolical form only. So what we have to do is that step 1, I have to write down the auxiliary equation. Write down auxiliary equation for 1 is given by Fm equal to 0. Note down, for this equation, auxiliary equation was given by Fm equal to 0. For this equation also, auxiliary equation will be given by Fm equal to 0. But this is obtained by replacing d by m and d dash by 1. When you replace d by m and d dash by 1, you will get Fm. So you will get Fm equal to 0, right? Now, there's a question, why do we replace d by m and d dash by 1? It's a separate question. This will be replied to in a short while. Now, this is Fm equal to 0. Obviously, for this Fm equal to 0, ordinary differential equation, this is a partial differential equation, we are finding the roots of the auxiliary equation. The roots of the auxiliary equation will be real and different. It could be complex or it will be repeated. Same here. This is same as Fm equal to 0. Roots may be m1, m2. It may be m1, m2 but both complex. And you know complex numbers occur in conjugate pairs, and it may be repeated. Say m1 equal to m2 equal to m. Okay. Next step will be you will find complementary function. Then you have to write down you will write auxiliary equation. Then you have to write the complementary function. Okay. See, second is say roots of auxiliary equation are say m1, m2, m3. Let me take up only 3 roots, or mn, doesn't matter. Then your complementary function is c1, not c1. It is function of y plus m1x, say phi 1, then phi 2 of y plus m2x, plus so on, function of y plus mnx. This is it. For this, you are having e raised power m1x, constant times e raised power m2x, so on, plus cn, constant times mnx. What is the reason? Why do we write it in this form? I will be explaining it. This is A. Now B is that roots of the auxiliary equation, say m1 or complex, say complex roots. Then say same roots are there, m1, m2, but these are complex. There is nothing to worry about. You have to write down in terms of function of y plus m1x, function of y plus m2x, function of y plus mnx. Here you will not find cos x and sin x because it was in your first semester for ordinary differential equation. It was e to the power mx, e to the power iota theta, e to the power complex number that was written in this form cos theta plus I sin theta. But here it is a function. Whether they are real roots or imaginary roots, you have to write down in this form only. Okay, I'll be explaining. And C is that roots are repeated. Say m1, m2, mn all are equal to m. Then complementary function is what? Function of y plus mx plus x times function of y plus mx. Just like in this case, it was c1 plus c2x e to the power mx. It is x. Then x square, another function y plus mx plus so on, x raised power n minus 1, function of y plus mx. This is it. This is how do we find the complementary function. For particular integral, I will be letting you know in my next talk on in this talk only. So let me find out why do we write this in this fashion. Okay. See, you have f d dash operating on z equals 0. In your first semester, you are having f d operating on y equals some function of x. Let me take up right hand side 0 in this case also. Otherwise, I have f d dash operating on z equal some function of xy, right? But I am taking right hand side 0. When it will be function of x, I have to find the particular integral. I will be finding only complementary function right now. For this and this, what is it? How do we do? You know, for this type of differential equations, the factors are of this form, d minus m operating on y equals 0. And the solution was constant e to the power mx. This I have explained in your first semester. For this type of equation, you will just now see roots of or factors of this form, because there are function of x as well as function of y. Roots are always of this form, d minus m d dash operating on y equal 0. You have m d dash also. You have function of x as well as function of y. Now, if I have a factor of this type, I do write solution as y equal constant times e to the power mx. But if I have a factor of this type, how to write the solution? This you have already done. See, what is d? D is del by del x. Operating on z, so this is del z by del x. Then m, this is del z by del y equals 0. Fine? So this factor can be written in this form. But what is this? This you have done. This is p. This is q equals 0. So this is linear form. pp plus qq equal to r. So what is the Lagrange's auxiliary equation? dx by 1, dy by minus m, dz by 0. This is Lagrange's linear form. And the solutions are obtained, you know, the four methods. Now one of the solution is there, see, dz by z, when the denominator is 0, so is the numerator. Taking this factor, we will get dz equals 0, which gives us z equals some constant, say c1. This is our first solution. Taking these two factors together, what we will get? dx by 1, dy by minus m implies y plus mx equals c2. So I have two solutions, c1 and c2. Now what is the method of writing the solution? c1 as function of c2, or c2 as function of c1, or c1 comma c2, function of c1 comma c2 equals 0. Let me write down c1 as function of c2. What is that? Z function of y plus mx. So this is a solution. If I have a factor of this form, d minus m d dash operating on z equals 0, solution is always of this form. Z equal function of y plus mx. You have already done in your formation of partial differential equation. I have first taken up this question only. Z equal function of y plus ax or y plus mx, and you know solution was of this form, del z by del x minus m del z by del y equals 0. You can see those notes, right? So solution is of this type. So if you have repeated roots, you have say m1, then m2, then m3, solution will be f of one function, then another function, then another function. How many roots do you have? If you have two roots, m1 and m2, you will get f1 fy plus m1x plus f2 y plus m2x. Same reason, you have the superposition principle. If y1 y2 are the solution, then c1 y1 plus c2 y2 is also a solution, right? And for repeated roots, you can see, I will show you, it will be x times. And for complex roots, you don't have to worry. Now, if you have this as a solution for this factor, d minus m d dash operating on z equals 0, solution is of this type. What is the, if you have a solution, you have d minus m d dash operating on z equals 0, and solution is always of the form function of y plus mx. What is del z by del x? You have m f dash y plus mx. Okay. What is del z by del y? It is 1 f dash. You see, अगर मैं एक और differentiation निकालूं, del 2z del x2. If I will find one more derivative, second derivative, third derivative, this will be m square, m cube, and so on. Second derivative with respect to y, third derivative with respect to y, this will be 1, 1, and 1. So you are replacing, this is nothing but d of z. This is nothing but d dash of z. You are replacing d by m and d dash by 1. That is why the auxiliary equation is given by fm equal to 0 again. Right? So this is it. So if I have, let me tell you, if I have repeated roots, say I have repeated roots, whole square, this means we have repeated roots. So repeated roots means d minus md dash, d minus md dash operating on z equals 0. Let me call this as u. You have d minus md dash operating on u equals 0. You have seen, if I have a factor of this type, d minus md dash operating on z equals 0, then z is given by function of y plus mx, solution. Now if this is operating on u, I have u equal function of, say, f2 of y plus mx. Fine? Okay, but what is u? U is d minus md dash operating on z equal function of y plus mx. But this is what? This is p minus mq equal function of y plus mx. This is a Lagrange's linear form, pp plus qq equal r. And what are the solutions? Solutions are dx by p, dy by q, dz by r. What is r? F of y plus mx. This is it. Now let me take up the first solution. dy by x, dx by 1, dy by minus m. Solution is y plus mx equals c1. Okay. Now let me take up this and this. What I will get? dz is equal f2 y plus mx dx. Okay, dx by 1, dz by this. So dz is equal to this. Now what is y plus mx? This is second rule. Say this is 1. Let me use this here. dz is equal to f2 c1 dx. Let me integrate it. Z is equal to f2 c1 x plus c3. So z minus or c3, chalo, z minus f2, what is c1? Y plus mx into x is equal to C3. Now I can write a solution. C3 as function of C1. Z minus x times function of y plus mx equals some function of say f3 of y plus mx. So this is it. This is a solution. X equal function plus x times function. When there are repeated roots, you have say m1 and m2. Z is function of y plus mx plus x times function of y plus mx. Right? So for complex, I don't have to write anything. If they are complex roots, then you have to follow first method only. Fine? So let me take up some questions. Let me take a first question. Del 2z del x2 minus del 2z del y2 is equal to 0. Or let me write down a square because you have done this question. Del 2z by del x2 minus a square del 2z by del y2 equals 0. Or this is d square minus a square d dash square operating on z equals 0. Or I have noted you down that this is r minus a square and this is t equals 0. You have done this question in our first lecture, formation of partial differential equation, second lecture. Now this is f d dash operating on z equals 0. So auxiliary equation is given by m square minus a square equals 0. You have to replace d by m and d dash by 1. I have just now shown why do we replace d by m and d dash by 1. So answer is, so auxiliary equation is m square minus a square equal 0. So what is m? It is plus minus a. So you have two roots, plus a and minus a. So what is the complementary function? Which is z in this case because the right hand side is 0. It is function of y plus ax plus function of y minus ax. If you go through in your second lecture, I have taken up this question. Formation of partial differential equation when z is function of y plus ax plus function of y minus ax. I have differentiated it partially twice with respect to x and y and concluded that the solution is given by r equal to a square t. So if in reverse direction, if r is a square t, I have the solution. You should appreciate this. How do we go from one step to another and back? Let me take up this question again. This is r, this plus this. Del 2z del x2 plus. This is r square plus t. A I have not taken. You can take a also, doesn't matter. So what is the symbolic form? It is d square plus d dash square operating on z, or r plus t equals 0, or m square plus 1 equals 0, replacing d by 1, d dash by 1. So m is equal plus minus iota. Alpha is 0, beta is 1. So you have m equal to iota. You don't have to write in terms of e to the power ax, cos and sine. What you have to write, what is the complementary function? It is function of y plus iota x plus function of y minus iota x. This is it. I have taken up this question also in your second lecture. Next. So you have del 2z del x2 twice del 2z del x del y. Let me write down minus plus del 2z del y2 equals 0. This is second order homogeneous partial differential. Homogeneous in the sense every factor is of degree 2. Earlier every factor was of degree 2. So homogeneity was there, homogeneity is there. So this is d square, or this is say r minus 2 s plus t equal to 0. You can write it in this form, or you have d square minus 2d and d dash, because this is with respect to x, this is with respect to y. Then d dash square operating on z equal to 0. So let me write down auxiliary equation: m square minus 2m plus 1 equal to 0, replacing d by m and d dash by 1. So what are the roots? M equal to 1 and 1. What is the complementary function? Z, it is function of y plus x, repeated roots, so it is x times function of y plus x. Fine. Another question. Say you have d cube 6d square d dash 11 d dash square 6 d dash cube operating on z equal to 0. This is a cubic in d and d dash. Okay. So what is the auxiliary equation? M cube minus 6m square plus 11m minus 6 equal to 0. This we have done in your first semester. Roots are 1, 2 and 3. You see, m equal to 1 satisfies this equation. You can use synthetic division. 1 minus 5, 6 and 6. Difference equation is m square minus 5m plus 6 equal to 0, which gives m equal to minus b plus minus 25 minus 24, which is 1 by 2, so it is 2 and 3. So roots are m equal to 1, 2 and 3. So complementary function, it is function of y plus x, another function y plus 2x, and another function y plus 3x. I have told you how many roots are there. Whatever roots are there, 1, 2, 3, so many functions will be involved. Let me take up next question. Say you have d cube minus 7d square d dash plus 6d dash cube operating on z equal to 0. D cube minus 7d square d dash plus 6d dash cube operating on z equal to 0. This is a cubic in d and d dash. So what is the auxiliary equation? M cube 7m square plus 6 equals 0, replacing d by m and d dash by 1. So what are the roots? See, m equal to 1 satisfies it. 1 minus 7, then x, m, 0 and 6. Okay. 1 minus 6 minus 6 minus 6 minus 6. 1 minus 6 minus 6 minus 6 and minus 6. So it is 0. So m square minus 6m minus 6 equals 0. What is that? M is equal minus b plus minus 36 plus 24. Is it okay? 7 1 I think this is okay. Okay, doesn't matter. This is plus 24 by 2a. So 6 plus minus under root of 50 by 2. This is alpha and beta. So you can write down, say alpha and beta is, so complementary function is function of 6 plus root 50 by 2 and function of 6 minus root 50 by 2. Okay, y plus, sorry, y plus this x, and this is function 1 and function 2, y plus 6 plus minus root 50 2x. Y plus mx, say alpha and beta, y plus alpha x, y plus beta x. Okay. Next, let me write down, this is a d and d dash square. D and d dash square. This is again a cubic and roots are m cube 7m plus 6 equal to 0. Replacing d by m, d dash by 1. Again 1 satisfies it. So the first equation will be 1 satisfies this equation. 1 minus 0 minus 7 and 6. 1 into 1 is 1. 1 into 1 is 1. 1 into 6 is 6. The first equation would be m square plus m minus 6 equal to 0. What's m? Minus b plus minus under root of b square minus 25. 25 means 5 by 2a. So minus 5, so it is 2 and minus 3. So minus 5 minus 1, 4. Yes, it is minus 2 and. So roots are 1, 2 and minus 3. So what is complementary function? Function of, which is third in this case, y plus x. Function of y plus 2x. And then function of y minus 3x. This is it. Let us take one more question. Say you have d cube minus 4d square d dash plus 4d d dash square operating on z equal to 0. D cube minus 4d square d dash plus 4d d dash square 4d d and d dash square 4d d dash square operating on z equal to 0. So replace d by m and d dash by 1. The auxiliary equation is m cube minus 4m square plus 4m equal to 0. Okay. So m into m minus m square minus 4m plus 4 equal to 0. So m into m minus 2 whole square equal to 0. So m is 0, 2 and 2. So the complementary function is function of y plus 0x. So function of y. Function of y plus 2x. Then x times, because these are repeated roots, x times function of y plus 2x. Okay, I think you got it. How to find the complementary function. Now let us come to the point particular integral. Now let me tell you one thing. See, for m equal to 0, I have got fy equal function of y only. See, what is this question equal? This is d times d square minus 4d and d dash, then 4d dash square operating on z equal 0. This question can be written in this form only. So when I have d only, not d minus md dash, d plus md dash. There is no dash, d plus. I have got f of y only. If it is d dash, if d dash is common, I will get f of x. You have to see it yourself. If I have d square means I will get f of y plus x times f of y. Write down, note down it. If I have d square, just like d, I have found f of y. If I have d cube, so you have 3 repeated roots. So function of y, x times function of y, and x square times function of y. All 3 functions will be different. And if I have d dash, I will get function of x. D dash square. So 2 roots, again function of x, and then x times function of x, and so on. Okay, I will be providing you notes. Everything is there, but then you have to remember it once for all. Okay, now let me take up particular integral. Now you have a question, say f d d dash operating on z equals some function of xy. Now how to proceed? When you were having fd operating on y equals some function of x, what is particular integral? Particular integral was x upon fd. For this particular integral is what? fxy upon fd d dash, right? I have to find this particular integral. What is this z? What is fxy upon fd d dash? So first of all, you know, for this the solution was complementary function plus particular integral. When right hand side is 0, solution is only complementary function. When right hand side is a function of x or function of xy, in this case I have to find the particular integral. So solution will be complementary function plus particular integral. Now you know how to find the complementary function. Let me tell you about particular integral. There are few methods available with us when we find particular integral of a function. Now I will give you first the general method. General method of finding particular integral of 1. This is 1. See, and you know this is the particular integral. Okay? Now pi fxy upon f d and d dash. This is particular integral. And you know factors of this. What are the factors of this function? These are of this type. F d m dash operating on z equal. Oh, sorry. Okay. F d. This is a okay. Doesn't matter. One of the factors. F d plus m d dash or d minus m d dash. Right? Doesn't matter whether it is plus or minus. So I will use to find the particular integral, to find pi, I will use the formula. क्या है formula? fxy. Let me take up only one factor, d plus md dash. Plus or minus doesn't matter. When it is plus, I will write plus m. When it is minus, I will write minus m. Is equal, if this is the case, I have one factor, this is equal integral of, for one factor I have one integral. For two factors I will be having two integrals. For three factors I will be having three integrals, and so on. Now I will take up integral one by one. So I have a factor, I will use f of x y equal mx plus c dx. This is it. Only this formula. Means I have to replace y is equal mx plus c. After performing integration, substitute back the value of c, which is y minus mx. Okay, this is it. This is the formula. This is it. Now, why do we do this? Let me explain you that. So, if I have a general question, f d d dash operating on z equal fxy, then particular integral, as you know, is given by fxy by f d d dash. To solve such equation, to find the particular integral, I will use this formula. D plus md dash is integral of x. I can integrate it with respect to x only when we replace y by x. So this is a function of x, I can integrate it. After integration, this will be a function of x, m and c. Now, c is a constant, I have to replace that, I will get again function of x and y, because c is in terms of y. So I will get a function of x and y. If I have one more factor, I have to use this formula. For second factor also, for third factor also, only when m's will change. Say for one question, I was having m equal 1, 2, 3. For m equal to 1, I will use this formula. For then m equal 2, for m equal 3. I was having say 2, 3 and 5, 4. I will use this formula accordingly. Okay. It is your choice. Whichever factor you will take first and whichever later. Doesn't matter, there will be no change in the answer. Now let me tell you why do we use this formula. Okay. You have to find the particular integral. See, why do we use formula? Why do we use formula? Say, you have say d plus md dash operating on z equal to function of xy. This is a simple question. This you have done right away. This is nothing but this is p plus m cube equal fxy. Okay. Now, this is nothing but Lagrange's auxiliary equations are dx by dy by and dz by. Okay. Now, how to solve this equation? Take up these two first. You will get y minus mx equals c. Say c1. Taking these two, this is dyx by 1, dy by m plus m. So dy minus m dx, so y minus mx equals c1. So what is y? mx plus c1. Doesn't matter, I have to replace always y by mx plus c1 when this is the case. If it is plus m, I will write plus. If it is minus m, I will write minus, right? Here. Now let me take up these two. I will get dz f of x, y, dx. Now in order to integrate it, what I have to do? I have to use y. Y is mx plus c or c1. Let me write c only so that you will compare it with earlier thing what I have said, mx plus c dx. So this is your dz. So what will dz? It is integral of f of x mx plus c dx. So if I have a factor, this is what is z here? Particular integral. It is fxy upon d plus md dash. See, your z is fxy upon d plus md dash. So if I have this factor, what is that? Function integral x, y replaced by mx plus c and integrating with respect to x. This is for one factor. This method can be repeated for so many factors. Let me take up the questions now. Say I have a very simple question. D minus 2d dash operating on z equal cos of x plus y. Right hand side is function of x and y. Now, auxiliary equation m minus 2 equals 0. So m is equal to. So complementary function is function of y plus 2x. Function of y plus 2x. Okay. Y plus mx. M is 2. Now particular integral. Cos x plus y d minus 2d dash. Okay. So what is m? M is minus 2. So y is to be replaced by mx plus c. And your m is minus 2. Your c will be y plus 2x. This is, I have to use it later, but I have to replace y by mx plus c. Your m is minus 2. See, if it is plus 2, it will be minus 2 over here, minus 2 over here, and it will be plus 2 over here. So I have to write 2x plus c, mx plus c. M is minus 2, so I have to write my equal to mx plus c minus 2x plus c. Accordingly, c will be y plus 2x. Now, let me use the formula. What is the formula? Integral cos of x replace y. Y is minus 2x plus c dx. This is it. Replace y by mx plus c. M is minus 2x plus c. So it is cos of minus x plus c dx. What is integration of cos? It is sine minus x plus c and minus 1 because it is minus x over here. Fine. Now this is the integration. Now after performing integration, you have to replace value of c. What is c? C is y plus 2x. Thus this is sine of minus x y plus 2x by minus 1. So it is minus sine of x plus y. So what is the general solution? CF plus PI. Function of y plus 2x minus sine x plus y. This is your z. Fine? Okay? Okay. Let me take up one more question. I think there is no problem now. I have not taken a solution here as constant here because this is the particular solution. I don't have to take C, constant integration. Say you have d square plus 3d d dash plus 2d dash square operating on z equals some function. Let me take up the function. Now what is the complementary function first? What is the auxiliary equation? M square plus 3m plus 2 equals 0. What's m? Minus b plus minus b square minus, so it is 3 plus 1, 2, 1 and 2. So roots are 1 and 2. So let me write down function of e to the power 2x plus 3y plus, okay, let me take only one question, one at a time. So complementary function is function of y plus x, function of y plus 2x. Particular integral is 2x plus 3y d minus 1 d dash d minus 2 d dash. Now there are two factors, one factor, another factor. For this y is mx plus c, m is minus 2. For this y is mx plus c, m is minus 1. So whatever factor you would like to take is your choice. Let me take a first factor here. First factor in the right, on the right hand side, y is mx plus c minus 2x plus c. For this, let me round c1. c1 is y plus 2x because there will be two c's. For this there will be one c, for this there will be another c. So let me take c1 and c2. So particular integral is e raised power 2x plus 3y d minus 1 d dash. Now let me write down in this fashion. This factor I have not touched, so I will write it in this form, 2x plus 3y d minus 2d dash. Now I will be taking up only this factor. So this is 1 upon d minus d dash e to the power 2x plus 3. What is y? Your y is minus 2x plus c1 integral dx. This is equal d minus d dash integral of e to the power, this is 2x, this is 3 to 6, minus 6, so it is minus 4x plus 3c1. Let me integrate it. This is e raised power ax means e raised power ax by a. So e raised power minus 4x plus 3c1 by minus 4, and this is d minus d dash. And now replace c. I was having y equal to minus 2x plus c1. So replace c1. This is 1 upon minus 4 d minus d dash e to the power minus 4x plus 3c1. What is c1? Minus 2x plus c1. So this is equal to e raised power this is minus 6, so it's minus 4. Now what is your C? C1 is y plus 2x, sorry, y plus 2x, y plus 2x, okay? Your C1 is y plus 2x, so it is 4x, 3 2s are 6, e raised power 6 minus, which is 2x, 3y minus 4d minus d dash. See, whenever you have to remember it once for all. If you have function of ax plus by type, whether it is sine function, cos function, log function, e to the power function, after replacing C1, you will get function back. In my first function, I was having some function, I got it back. In this function, I had the function 2x plus 3y, I have got it back. And finally, in the third, this factor, I will also get it back. Okay, so remember it. Whenever you have a function of this type, ax plus by, you will get it back. Now I have one factor, and for this, your my is mx plus c1 or c2. Your c2 is y plus x. Fine. Now let me use it. Minus 1 by 4. This is integral e raised power 2x plus 3y. Your y is minus x plus c2. So this is it. Minus 1 by 4 e to the power minus x plus 3c2. Okay. Now let me integrate e raised power minus x. Is e raised power minus x plus 3c2 divided by e raised power minus x means e raised power minus x by minus 1, so it is plus 4. Minus minus plus 4. So replacing, after integration, you have to replace value of c. Here it is c2, which is e to the power minus x plus 3c2. c2 is x plus y by minus 4. This is e to the power 3x minus x, it is 2x plus 3y by 4. Okay. Let me give you, there is one more method, simple method. I will be using it later, but this is it. How many factors, how so many factors you will have? You have to use this formula only. Let me take one more question and say you have d square minus 2 td dash plus d dash square operating on z equal, say, y minus 1 e raised power x. Okay. Now this is of the type, this is not of the type function of ax plus by. So you will not get back the function. You cannot get back. If it is ax plus by type, you will only then get function back. Otherwise not. So complementary function you have already done. Okay, let me write down. Your m is 1 and 1. So complementary function is function of y minus x and function of, these are repeated roots, y minus x. Because this is m minus 1 whole square. M is 1 and 1. This question we have already done. That's why I have not taken 18th. So particular integral y minus 1 e raised power x divided by d minus 1 d dash whole square. So m is minus 1. I have to replace y by minus x plus c. This is repeated, so I will write it twice integral. Okay, this is integral y is replaced by minus x plus c e raised power x dx 2. Now this is very simple, you will do it. Will you? This is first integral is by parts. You will do it by parts. Do it. आप बच्चे नहीं है ना, बड़े हो गए हो. So you will do it. This is by parts again and again. You don't have to replace c for first because c is the same. C is same. You will get same thing. So you don't have to repeat. If you replace c for once and for twice, you will, end up with the same thing. So you have to integrate it twice, and then after integration you replace value of c. C is x plus y. Okay. Next one, or you will do it yourself. Let me show you the simplest form. Another method, shortcut method. Let me write down shortcut. If you have f d d dash operating on z equal some function of ax plus by. I have not written now function of xy. I have written a function of ax plus by type. Then complementary function, you know, particular integral is function of ax plus by f d d dash. I will be sending notes to you regarding this today, but I will explain you here only. I will not write down much. This is nothing but, say this is a function, say f d d dash of is a second order homogeneous partial differential equation, or third order or fourth order. So you will be having factors. How many factors? 2, 3, 4. You will end up with these factors. So what you have to do is, what is the particular integral? You will replace f d by a and d dash by b, and integrate this function as many times as the degree of this function. Say f d d dash is of order, say, n. So you have to integrate it how many times? N times. But replace d by a and d dash by b. For example, if you have d minus d dash d square plus 3 d dash 2 d dash square operating on z equal e to the power x plus y, say. Auxiliary, what is the auxiliary equation? Minus b plus minus under root of 1 by 2. So it is minus 2 and minus 1. So complementary function is function of y minus x and function of y minus 2x. This is already known. Particular integral is e raised to power x plus y d plus d dash and d plus 2d dash. Okay, d plus d dash, d plus 3d dash. What I am saying is that you have to take it as a one function. Particular integral is e to the power v. Replace d by a. This is ax plus by. A is 1, b is 1. D by 1, d dash by 1. D by 1, d dash by 1. And integrate this twice with respect to v. You have to take it as a symbol variable. So e to the power v means e to the power v twice. So e to the power v, this is 2 and this is 3, this is 6. And after performing integration, replace value of v. This will be it. If you will do it in general method, by general method, using one factor, then another factor, replacing y by minus 2x plus c, then replacing y by 1x plus c, you will end up with the same solution. Fine? So this is the simplest. You are replacing d by a, d dash by b, and integrating it. Okay. If you have f of ab, one condition is there, f of ab is not equal to 0. If f of ab is equal to 0, then you have to use those formulas which you have done already in your first semester. Okay, so I will end up my talk over here. I will be forwarding you notes regarding this. You will apply both rules. Whether this rule is very simple now. You have to replace d by a and d dash by b, integrate as many times as the order of the differential equation. This is very simple. And for this general method, you have to use first factor, replace c, second factor, and replace c. This is it. This is linear differential equation with constant coefficient end up. This is linear homogeneous partial differential equation finished. I will be taking up non-linear now. Non-homogeneous, and after that non-linear. Okay. Non-homogeneous means what? You don't have homogeneity. See, d minus a d dash. This is homogeneous one. Homogeneity is there. This is d, this is d dash of degree 1. But let me suppose that this is b over here. This is not homogeneous. I have shown you in my formation of differential equation. I have taken up a question. Say z equal e to the power bx function of y plus ax. This is its solution. This is non-linear, non-homogeneous part. So if you have a factor of this type, how to find the solution, I will be taking up in my next lecture, not now. This is in fact minus. So okay, so let me finish up this over here. I'll be forwarding notes explaining everything which is over here, which I have delivered today. I'll be forwarding notes as well as this video to you. Thank you very much.